Hey everybody, this is 6.3. We're going to be talking about radical function applications. So sometimes you'll find equations that kind of model a radical function, and we're going to use that to maybe solve some problems and find what's being asked. Anyways, so we're going to talk about tsunamis. So tsunamis is a giant wave caused by earthquakes or volcano eruptions under the sea. Out in the depths of the ocean, tsunami waves do not dramatically increase its height, but as the wave travels inland, they build up higher and higher heights as the depths of the ocean decrease. So you see this water's moving, and it has a lot of area for this water to move. But as the beach gets higher and higher, that water has to be pushed somewhere, and it makes the water go higher and higher. So the speed of the tsunami waves depend on the ocean depth rather than the distance from the source of the wave. Tsunami waves may travel as fast as a jet plane over deep waters, over only slowing down as it reaches the shallow waters. While tsunamis often refer to tidal waves, this name is discouraged by author blah 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 blah. Okay, so the velocity, here's our equation that we have over here on the right side. This is our equation. It relates the velocity miles per hour of the tsunami related to the depth of the water, which is x. And it wants us to first use our graphing calculator to model the function described above, and then answer some of these questions afterwards. So just to keep it kind of simple, you can use your graphing calculator, pull it in. You might need to change your window a bit, but just as kind of like a rough estimate of what's happening here is we have the depth, and here we have the velocity, and our equation should look something like this. Okay, it really depends on how you set up your window, but okay, so that's that. I think maybe what's more interesting is being able to calculate what's being asked for number 2. At what depth does the velocity of the tsunami hit 100 miles per hour? So just keep in mind that velocity is our v, and our depth is our d. And they're telling us that the velocity is 100 miles per hour. So we have the equation, we can plug it in, and we can solve for what's being asked. So we know what v is, or what we want it to be. So let's plug that in. We'll have 100 is equal to the square root of 35.152x. And we're just going to want to solve for that. So how do we get x by itself? Would maybe start by squaring both sides. So kind of go back to what we did last time. If you haven't done the assignment for 6.2, I'd encourage you to do that first. So here we'd end up getting 10,000 is equal to 35.152x. And then the last thing to get x by itself is we would want to divide both sides by 35.152. So if you use that and plug your calculator in, that will give us our answer. X equals 284.5 miles. All right. For 3, it just asks if you found that information by using your graphing calculator. It asks you to do it algebraically. So we already got that covered. All right. So let's look at a couple more examples. I think we're just going to do these 3. Oh wait, no, there's some more on the next page. We'll go through all of those. Won't take a lot of time. So it says the meteor crater in Arizona is modeled by this equation, where it relates the diameter of the rim in meters to the volume in cubic meters. The distance is 1.2 kilometers or 1,200 meters. What is the volume of the meteor crater? All values are approximate. So basically we're going to plug in what we do know and we're going to solve for the things that we don't. So here we're going to plug in, we know the distance. The distance D is 1.5 kilometers. We're actually going to keep it in meters. So we want to kind of keep the same units as when we are doing these types of problems. All right, so our distance is 1,200 is equal to 2 times the cubed root. So this is kind of new. This is still a radical function, but we're using a cubed root instead of a square root. And we just want to solve for v, the velocity, or sorry, volume. Okay, so kind of do the same thing we did before, kind of doing PEMDAS backwards. We'd maybe want to get rid of this 2 because it is multiplication. We'll just divide both sides by 2. That will give us 600. The next thing would be our exponent, which is our cubed root. And the opposite of cube rooting is cubing. So we'd need to cube both sides. And this is kind of a bigger number, so you probably want to use your calculator for sure. Here we get yeah, I'm not even sure what that is. 216 million. And then the last thing we'd want to do is get rid of that 0.3. So it's being divided, so we need to do its opposite. We need to multiply it by 0.3. So we end up getting, again, you want to use your calculator to do that, we should end up getting 64,800,000 meters cubed. So that's quite a big volume. All right, next off, the radius r is a sphere, is given by this function, where v is the volume of the sphere. Solve for the equation for v. So we want to solve for the volume. Okay, so without doing any numbers or anything, we're just going to do the same sort of thing. We're just going to keep the variables how they are. So again, PEMDAS backwards, there's nothing outside of that cubed root. So we'd want to maybe get rid of that cubed root by cubing both sides. So we'll get r cubed is equal to 3 over 4 pi times the volume. Okay. Next off, we maybe want to get rid of this. How we can do that is we can multiply it by its reciprocal. It's basically like you're multiplying and dividing that step all at the same time. So if we multiply it both sides by 4 pi over 3, again the 4 pi and the 4 pi here cancel, the 3 and the 3 cancel. So we end up getting v, the volume, is equal to 4 pi r cubed over 3. So that would be our answer here, and then I think the next problem asks you to use our problem from problem 2, or answer from problem 2 to answer problem 3. So a spaceship Earth is a spherical structure in Walt Disney World that has an internal radius of 25 meters. Use the equation from problem 2, find the volume of the spaceship Earth. So 25, that is our radius. So we're just going to plug that in. So v equals 4 pi and then 25 cubed all over 3. And we just want to maybe use your calculator. Don't try and do that by hand. Plus, we're going to have like a pi. You're going to have some sort of decimal, and we'll round. So I'm just going to round it to the whole number. So 2,618 meters cubed. All right, next off, the period p in seconds of a pendulum is given by this function, where L is the pendulum's length in feet. It says a pendulum has a period of 4 seconds. Is the pendulum twice as long as a pendulum with a period of 2 seconds? So let's kind of leave that part to the end. What we're going to be doing is we know the seconds, we know the period, and this is also a period. So if we want to compare their lengths, it might be best to first solve for L, and then we can just plug in those values and see how their lengths turn out. So if we want to get L by itself, the first thing we'd maybe want to do, maybe I'll rewrite it over here. Okay, so we will want to get L by itself. So we'd maybe, this is being multiplied, so we'd want to divide by 2 pi. That would cancel. Next thing what we'd want to do is we'd want to get rid of that square root. So we would want to square both sides. So now we have p over 2 pi squared is equal to length times 32. And then our last thing we'd want to do is multiply both sides by 32. So that gives us our length. Length is equal to 32 times p over 2 pi squared. So let's see what happens. What would be the length of a pendulum that has a period of 4? So period of 4. So we'll just plug that in. And then I would just use your calculator. So once we have that typed into our calculator, we end up getting approximately, around a little bit, about 13 feet. And if we do a period of 2, again, we're just change that to be 2 instead of 4. We'll end up getting 3.24. So let's see if we can answer that question. Is this pendulum twice as long as a pendulum with a period of 2? So comparing these two together, is 13 twice as big as 3.24? No, it's actually it's 4 times as big. If we were to take 13 and divide it by 3.24, it ends up giving us about 4. So it has to be, if we double the period, we need to quadruple the length of the pendulum. Okay? All right. Last two of these are pretty simple. Let's try and go through these. It says find the value of x given the perimeter of a rectangle is 22 centimeters. So you got to remember what a perimeter is. So a perimeter is adding up the sides. So we'd have 2 times of the lengths, because we have 2 lengths, plus 2 of the widths. So this would be a width and this would be a width, right? So we want to add those all up. We know what the length is, and we know what the, I guess we know like pretty much a lot of this stuff. So perimeter, it says, is 22. Length here is 4. And width is the square root of 6x minus 5. And solve just like we did before. So we got 22 equals 8 plus 2 square roots of 6x minus 5. And then we're just going to do PEMDAS backwards. So subtract 8. That's our adding or subtracting first. So that gives us 14. Equals 2 square roots of 6x minus 5. Next we have any multiplying or dividing. This is multiplying, so we'd divide both sides by 2. Next we have the exponent, or the square root, so we'd square both sides. And then we kind of repeat the process. Add 5. So 54 equals 6x. And then we need to divide both sides by 6. So x ends up being 9. Okay, and if you wanted to, you could plug 9 into the width, and you could actually find the value for that if you wanted to. Last example, find the volume of x given the area of a triangle. So remember that the area of a triangle is 1/2 base times width. So this could be like our base, and this would be our width, and A is the area, which we are given that. So the square root of 5x minus 4 is equal to 1/2 base, which is 2, times the square root of 3x plus 12. So the half and the 2 would cancel, and we just want to get x by itself. So we'd square both sides. Get all your x's on one side, so subtract 3x. And also would want to add 4 to both sides. So we end up getting 2x equals 16, or x would be 8. Okay, again, you could plug that 8 into this to find what the actual width would be. All right, well, if you have any questions, please stop by, and we'll see you later.